Hello, this is week 1 of Intro to GIS. In this presentation, we'll be talking about what is GIS, some definitions, some background, some history of GIS, and some, uh, you know, different examples of GIS on different fields. Also, we'll talk about ARCMAP itself. I'll show you around the software and maybe get yourself acquainted with the software, and do little things like adding layers, playing with the layers, playing with the software itself. So we'll get you started for the next 8 weeks today. So what is GIS, which is actually a great question. Even better question is, what do you know about GIS? Why do you think GIS matters, or what do you think GIS can do? So I would recommend, actually, you have to go to the Blackboard and fill out this discussion board, post your own stuff, personal experiences, what you know about GIS, and maybe it's related to work, it could be the reason why you're taking this class, anything you know about GIS, just post out there, post on the Blackboard so that I know what you guys are thinking, where you guys are coming from. So why do you think GIS matters? The main reason GIS matters is all the decisions we take in our lives are geography based. Where shall we go? Which restaurant is the best restaurant that is close to my workplace or my to my house? Where should we buy a house? Where are the good school districts? Where are is it close to my workplace, or are the prices low? How's the market doing? Or is it close to a grocery store or not? Can I get like decent pubs and nightlife close to my place? Or if you are like a business owner, you need to think about where are my customers, current customers, future customers, where is my future market, so on and so forth. All these decisions are essentially based on geography. You might not think about it that way, but it is, you are thinking about geography all the time. So that's why information on this geography is very critical in helping you make these decisions. So GIS does matter. So by now we know almost everything happens somewhere. It doesn't happen nowhere, because like a crime or a construction of a house or a bridge, or a location of a customer, something, almost everything happens somewhere. And where the knowing the where is extremely critical, because it will change your decision, or it will help you make a decision. If you are a city planner, your county boundaries matter, your location of hospitals matter. If you are and then if you are like a FedEx delivery service, your routing matters. What is the shortest route? Knowing the where, almost it's like the basic question. That's why GIS is so critical in our day-to-day lives. So you might not think it this way, but you already have some experience with GIS. Like, you might have used Google Maps to actually find the best route to travel to Chicago or DC or whatever. Or you might have used it to find like a restaurant, closest restaurant, or a good hospital, or a good hair salon, or whatever that is. You already have benefited from a GIS system like Google Maps or Bing Maps or any other mapping system, or even Google Earth for that matter. You wanted to look how cool your street view looks on Google Earth, sort of a thing. So all this stuff, these are applications of GIS, Geographic Information Systems. So you might not have realized it, but you're already using GIS in your day-to-day lives. You might not be designing them or using them to their full extent. That's why you are taking this class, to learn about more enhance your knowledge on GIS, on how to use this better, so that eventually it will make you more money, hopefully. So what are the advantages? There is the first and foremost that comes to mind is improved presentation quality. Like people say, a picture says 1,000 words. The same goes with maps. Instead of giving them 10,000 records of rows of data, if you give them a simple map depicting the same data, it will be a lot more powerful. And the best part about GIS is that you can integrate different databases into one, like a centralized database, and sort of like do this overlay analysis based on all these different types of data, which is extremely critical, which you will realize moving forward in this class. And the data is live. You can update this data, you can dynamically change this data, which is extremely critical. This is not like a static map where you have to reinvent the wheel in a way. If you have like if you have a printed map, you can't do much with it. But if you have a GIS database, you can change it interactively, you can play with it. And then there is advanced analysis, which actually is fantastic. This is used in this is being used more and more in all the business, all fields. You talk about medical field, or real estate, or planning, or transportation. Advanced analysis using GIS has become a day-to-day activity for all these analysts in these different fields. So it is a huge advantage that GIS provides. So what is GIS? Going by the definition, it's a computerized system designed for the storage, retrieval, and analysis of geographically referenced data, which is actually that's GIS. It uses advanced analytical tools to explore at a scientific level the spatial relationships, patterns, and process of cultural, biological, demographic, economic, geographic, and physical phenomena. I would like to think of GIS as intelligent maps. Maps that can talk to you, that can provide you with knowledge which is otherwise not available. So you can combine different sets of data using, like we can combine census data, we can combine socioeconomic data, we can combine business information, and using all this information you can create we can analyze these spatial relationships that will help you make different types of decisions, which we will see in some examples later in the class. So the unique capabilities of GIS. By now we already know that GIS sort of like brings together a database and the spatial relationship, or brings in the location factor in. So what it also does is easily let us reuse the data in a way that we can compose maps quite easily and make different presentations, which will help us in the decision making process, or identifying patterns or trends or something like that. The unique capability is that it has something called map layers. All this different data is actually stored as map layers, and you can interactively change them and compose them in a way it'll be easy for you to do like an overlay analysis with this. So yeah, GIS, that's the most unique capability. So you can bring in census track layers, which has demographic information, and at the same time you can have roads and schools or businesses or some other information, and you can create thematic maps based on median incomes or population growth or population density, all this different stuff, so that you can easily overlay all this different information quite easily. To be honest with, that's the best part about GIS, is that once you set up the data, it's gonna be extremely easy for you to create all these different maps that will help you with your analysis. So GIS answers the following questions. It answers questions on location, where is something, what is something. You already experienced this kind of a thing with Google Maps or something, where you are able to find features like restaurants and schools or movie theaters, whatever that is. And then you have something called answers questions about conditions. So if you have like a parcel database, it will answer you questions on whether taxes have been paid, or whether the building has been dilapidated, or in what condition the building is, and or questions about trends, what has changed since 1990 or 2000 or 2010. Is the population growing, or is the population receding? All this very critical stuff. It will help you analyze the trend, and it will also help you analyze patterns, like whether there is a spatial relationship between, or spatial correlationship between, concentration of incomes and location of shopping centers, or it will help you understand the relationships between median incomes and good school districts, stuff like that. And it will also help you model stuff, which is what if I start a shopping center at this particular location, would that give me better sales? Or if I move to a new location, would I get better sales? Or what if there is a new store, how would the sales of my store be affected? Very advanced modeling, gravity models, probability models. So GIS can do it all. This is a extremely powerful tool that will help you do help you create simple presentations to extremely advanced analysis. So let's define GIS. There are different definitions, but we all realize that the one unique factor that's going for GIS is that the data is linked to maps or spatial data. So a GIS at least consists of a database, map, and it has map information and a computer link that exists between them. So what is spatial and non-spatial data? Spatial data is nothing but something with a location. Look at these two tables right here. One has bicycle parts, which has nothing to do with spatial data. It has part numbers, quantity, descriptions, nothing that indicates location. But look at the second table, which is crimes during 2003. It has date, location, and type of crime. Obviously, the main factor, the unique feature of this table is location. It differentiates. That's the difference between spatial and non-spatial data. So what is GIS again? So it's a combination of hardware, software, network, people who can actually work with GIS, and data, and then the procedures or the models that will help you analyze this or process this data. Defining GIS, think about GIS as a toolbox. It's a powerful set of tools for storing, retrieving at will, transforming and displaying spatial data from real world for a particular set of purposes. So there are different variations, but one definition has definitely survived the test of time, which is the following. A GIS system is a special case of information systems where the database consists of observations on spatially distributed features, activities, or events, which are definable in space as points, lines, or areas. A geographic information system manipulates data about these points, lines, and areas to retrieve data for ad hoc queries and analyses. So this is the best definition, and you will understand, if you are able to understand this definition by the end of this course, that means you can claim GIS. So the feature model is, it's a Duker's definition uses feature model of geographic space, which means essentially it says all the features on Earth can be classified into three different features. One is points, lines, or areas. Using GIS, like a road is a line, or a parcel, or a lot is a polygon, or a city is a polygon, or a river is a line, and there is like a schools or addresses or points, so on and so forth. What Duker says is that all these features can be classified into these three features: points, lines, or areas, or polygons. So, and GIS involves capturing the spatial distribution by measurement of the world or of maps. So he also claims that all human activity and natural phenomena are spatially distributed, which we already talked about, so it can be studied using GIS. And GIS uses map features to manage the data, which is the most unique feature about GIS. So the same thing. So the points here are survey points. It could be and then the lines are actually the contour lines, and the areas are essentially a reservoir or a floodplain or something like that. So GIS is flexible enough to be used for ad hoc query and analysis in space about place, and GIS can do analysis, modeling, and prediction, which we already talked about. So that's the definition of Duker. And now that we have defined GIS, talked about what GIS can do, and looked at its unique capabilities, let's talk about why you need to learn this stuff. That's a very important question. You need to understand the purpose, understand that you're excited about GIS, but you need to be excited because it's an important skill in the job market, especially given how competitive the market is right now. You need to have this skill because this skill will earn you more money, as simple as that. So you can read all the stats, but I'm not gonna go deep into this because let's just say certified GIS professionals do make more money than non-certified or people who don't have GIS knowledge. And then let's focus on this, which is the ArcGIS or ARCMAP software, which we'll learn, which says that 90% of the market, GIS market, uses this software. So you are in the right class if you want to be part of the majority which uses the most popular GIS software. So history of GIS. GIS, the origin of GIS lies in thematic cartography, which is the science of map making. Many planners use this method of map overlay using manual techniques like tracing paper and trying to recreate the same things again and again so that they can use it in the as a final map. Essentially, it's a town planning technique. So as you can look in this town planning textbook, they try to overlay different things like rock types, sites for preservation, farmland, population distribution, communications, to come up with a scheme for agricultural development. This is the basic map layer overlay principle. This is the basic for map overlay principle. Overlaying all these different layers, coming up with a scheme for development is essentially what GIS does. So in 1960s, we saw new forms of data and mapping software, and it didn't really kick off till the 70s and 80s, but there were softwares and modules, software modules rather than standalone programs. World Bank initially was influential in creating these data sets for their own analysis, and then there were pioneers in education like Harvard, which developed their own software to actually analyze this geographic data. So it changed drastically by the time there was something called a PC or a workstation, and then there is internet in the 90s, which actually revolutionized the whole thing. In the 80s, new GIS software came into the picture, trying to exploit this new advanced hardware, and these developments led to a vast improvement and ease of use during the 90s. Believe it or not, when I started using GIS in 2000, that was still DOS based. We had to use something called ARCInfo 3.5.1, which was essentially like a MS-DOS program, and it was a challenge to work through it, trust me. And then we moved on to ArcView, which is essentially like a presentation software. It didn't have any editing capabilities, and then they combined these two to actually come up with something called ArcEditor, ArcInfo, workstation sort of a thing, and then it moved on to slowly ARCMAP, which is what you'll be using today. So let's talk about GIS data and GIS data layers. So the scale of GIS data is very critical, because what the type of feature, whether it's a point or a line or a polygon, changes from where you are looking at it. If you are looking at the world map, St. Louis is essentially a dot. Essentially, it's not it's a dot on the map. But if you actually zoom in to St. Louis, zoom into the state of Missouri, or maybe zoom into the region of St. Louis, St. Louis is more than just a dot, it's an area. So the scale of GIS data matters a lot. So think about it when you actually start working with GIS data. So we already know there are three types of vector data: polygons, lines, and points. And then every feature has an attribute. That's the unique feature of GIS is that every feature has an attribute. For example, let's say there's a polygon field called census tracts. Census tract will have a shape and a name and a maybe there's population of 2000 or a state to which it belongs. And then there is raster data, which is actually images, aerial photography, stored in electronic image format. So it's essentially squares. If you keep zooming in to this raster data, it's essentially like cells or pixels is what they call. So this will be like small tiny squares if you really zoom in, and then you can see these squares. But these raster data does not have any associated data with it, because they are not vector data. They don't have points and lines and polygons in them. It's just pixels, so you can't really have data at a pixel level. There are some exceptions, but we'll talk about that later. So GIS example, identify, for example, let's talk about this. So we are trying to identify polluting companies and their proximity to populations in poverty. So talk about environmental social justice. So what you do, you start with databases and map layers. So if you look at this database right here, it says this is census tracts and poverty. It has poverty information, and poor families and so on and so forth. And then you have all these different industries and their latitude and longitude. What are you going to do with this data? There is nothing that combines this data or interprets this data which will help you analyze these patterns. And here comes GIS. So the same data in GIS can be shown as this. So you create a thematic map or color code the map based on overall poverty, percentage below poverty, which is the black and the gray areas, the darkest or the blackest areas representing the poorest, and then the polluting industries are overlaid on top. Now you can actually look at the patterns and see if there is a correlation between poverty and social justice. From the first look, it looks like there is probably, and additional this is just a starting of an analysis. You can't really conclude anything based on this, but it sort of gives an example on how to start looking at data. And then you can obviously add political features and municipalities on top, and physical like lakes and schools. And eventually you can um, excuse me, you can overlay all these layers and start analyzing these patterns. You can select the features, and you can sort of like do proximity selection. Say select all the polluting factors within 0.25 miles of a river. So it's going to select all the rivers which are within 0.25 miles of a water body, and then you can probably create like buffers around these polluting industries, and select all the schools within which within 2 miles of these companies, all the schools, and probably create like an index and come up with strategies or policies to probably relocate these industries, or maybe put additional regulations on them. So this is the way you actually use GIS data in your decision making process. So let's talk about applications of GIS in general. So GIS is used in civil engineering and surveying, and then it is used in business sector for site location or marketing purposes, and real estate. It is used by the defense. One of the most primary uses of GIS is defense. Defense applications, because they use this geospatial intelligence to actually collect information on war and other strategies. And then there are government users to come up with like public policy regulations, and there are election users. All you see during election season are these maps on these touch screens, trying to analyze who is voting blue or who is voting red, sort of a thing. And then there is health sector, which uses this in public health and human services, and management of hospitals. And you talk about GIS, and it's not like restricted by a field. Geography doesn't belong to one field. There are uses for geographic information in different fields, especially public safety and transportation and communication. So what I wanted to get across to you is that GIS is a huge field which you can use in any. Once you have the basic understanding of GIS, you can employ that skill in any of these fields. So let's talk about real estate, since this is slightly related to real estate discourse. And so location drives real estate industry. It's all about location. We know that. And there are different players in the real estate market, like home builder, commercial real estate agent, or property management company, or multiple listing service. All they are trying to do is find the best site. So what GIS does is it will help you bring different sources of data, like market potential data, aerial photographs, traffic counts, demographics, shopping centers, and competitive influences, and it will help you analyze this information and help you find the best site. So it's a very powerful thing. And so the GIS structure that I use for most of what I do is laid out in this fashion. We have census data, and we have business information, we have street data, we have proprietary data that we build in house, and then we got aerial photographs, and sometimes we gather information from the cities at a property level or a parcel level information, and that all feeds into a centralized GIS database using ArcGIS ARCMAP software. I create maps and reports and data on a regular basis. So that's my job. In case you're wondering what I do, this is what I do. I work with economic development department, I work with my planning department, I work with my real estate department, and feed them with these critical pieces of information that will help them understand, come up with policies and decisions. So some more examples. So if you talk about market analysis, you need to come up with market areas and so on and so forth, which you will use to actually create some demographic reports for your markets. And this is extremely critical because once GIS will help you bring all this data together, including maybe creating like a area amenities map, which will show the closest facilities to your site, and maybe create a map of like comparable properties, which if you're doing an appraisal, comps are like the most critical thing. So you need to sort of show their relationship with the subject property. So GIS will help you do this quite easily. And then GIS is used for as a presentation tool. This is an example of a Doran. It's a mining company, I believe. So what we are trying to show is the impact of this company on these different counties. And this first map is one way to show this, but you can also show it in sort of like a 3D way, which could be useful in different situations. So again, talking about GIS analysis, this is Kansas City, where you are trying to analyze the population growth or understand the region. I'm looking at where are the hottest areas for growth. Obviously, our study area was Lee's Summit, the city of Lee's Summit. So analyzing this spatial data, analyzing the census data and creating the spatial analysis map helps us understand where Lee's Summit stands with respect to the region. And then we can talk about like data in population, which is essentially job densities and median disposable incomes, and see what are the hottest areas or the people have the most money to actually spend on things. So this is all done using GIS, and GIS can also help you understand gaps in the market. Like, so this is St. Louis. So we are in this map. What I did was I created an income density overlay, and on top I overlaid some of the shopping centers, the main shopping centers in St. Louis area. As you can see, there is a relationship between income density and location of shopping centers, and obviously we try to look for like gaps in the market based on this is the mercantile exchange analysis that we did. And then if you want to talk about gap analysis, there's this if you want to come up with like an affordable housing project, so what is the best place to look at this project? So you can create a map of density of qualified income households, and then try to overlay the existing markets, existing properties, affordable properties, and look at the spatial patterns and try to identify gaps based on that. So, and also we can use GIS to analyze the feasibility of a project like a soccer facility, or a soccer town is what they call. But anyways, what we are required to do is analyze if there is a market for a soccer based retail center. And you can obviously see we mapped all the soccer facilities and try to analyze the market and see if there is competing forces within the market area and so on and so forth. So we can also use this for site potential and market penetration analysis. This is St. Petersburg, Florida. Somebody wants to build a shopping mall. So our task was to analyze how much this shopping mall would generate in terms of market sales per square foot or a period of time. So GIS using gravity models and existing competition and income, disposable incomes, we were able to determine this as the potential for the site. So software overview, I'm not gonna go into real details here. I'm just gonna show you the main things that you need to know before we actually jump into the walkthrough of the software. So ARCMAP, well, it has a main menu. This is the software interface, and there is a table of contents where you see the map layers, and there is a toolbar which you actually use to zoom in, zoom out. There is a pan button and like a global view and fixed zoom in, zoom out, forward extent, back extent. I'll explain all this. I'll show you these in action. And there is the identify feature where you can use that to click on any of the features and it'll pop up a window, the identify window, to show the results. And then you can measure features, and there is a find button, and then there is find XY, so on and so forth. And this is the standard toolbar where there is a new map, open map, save map, print, and cut, paste, and all that good stuff. And this is the unique button, the yellow layer with a plus sign, the black plus, and that's add data. And there is a scale drop down indicator which actually shows the scale of the map it's in. And then we'll get into this stuff. There is this ARCTOOLBOX, ARCCATALOG, and there is model builder and magnifier window and Python window, so on and so forth. And there are two different views. The main view is the map document window, this one right here. This one right here is the map document window. What else? Moving on. So the map documents are saved with a .mxd extension and points to, essentially, map document doesn't mean it has any data in it. It is merely sort of like it's a referenced map document. It sort of like pulls the data from different sources and presents them or colors them, but it doesn't actually save the data itself. It saves the layer, colors, and symbology and stuff. So tutorial 1.1 will actually work with this. There are two layers, US cities and US states. We'll try to add them to a map, and we will see how this all works. So there are a couple of terms you need to be familiar with. One is geodatabases, the other is shapefiles, ARCCATALOG, ARCTOOLBOX. So geodatabases is essentially a container of feature classes or data sets. It contains GIS features or tables or raster images, etc. So they look like this. When you look through, the ARCCATALOG is nothing but like a file viewer, except that it is used to view GIS files. It's sort of like a file browser, like your Windows Explorer. It's sort of like used to arrange and manage geographic information in workspace folders and geodatabases. So if you look at this, I'll show you these files in action. It'll make more sense to you. And then there is ARCTOOLBOX, which is a combination of all the tools that there are. It's sort of like a one-stop. So you go here to find any tool you need to essentially find in ArcGIS or ARCMAP. Advanced tools, you can also create your own tools here, but this is like sort of like it's sort of like a database of all the tools. So let's in the next presentation, I'm going to dive right into the tutorial workbook and start working with get started with chapter 1 of the book, and then you'll start to understand what I'm talking about, ARCTOOLBOX, all the shapefiles and stuff, and I'll show you the interface in interactively. Okay, see you then.